Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the single most important pattern for any AI app that touches private data. And the reason it exists is a problem you've definitely hit. Ask a model what's our refund window for enterprise plans. It has never seen your contracts. So it does the worst possible thing. It invents a confident, specific number.
Right, and a confident wrong answer is more dangerous than I don't know because someone acts on it. So the fix is you slip the real policy paragraph into the prompt right when the question is asked.
That's the whole idea. And the name is retrieval-augmented generation RAG. The trick is to find the one relevant paragraph out of, say, 200,000 documents in under a tenth of a second and stuff it into the prompt before the model ever sees the question. Then you tell the model, answer using only this context. Now it's reasoning over text you control, not over whatever it happened to memorize in training.
Okay, find the right paragraph out of 200,000 documents in a tenth of a second sounds like the impossible part. How does that search even work? You can't keyword match your way to that.
And that's the heart of it. Embeddings. An embedding model maps a piece of text to a fixed list of numbers, a vector, with one magic property. Text that means similar things land near each other in that space. So refund policy and money back guarantee end up as neighbors, even though they don't share a single word.
So you're searching by meaning, not by spelling. And how do you measure near each other for two of these vectors?
Cosine similarity. The cosine of the angle between the two vectors. Point the same direction, you get 1, that's similar. At right angles, you get 0. Unrelated. The reason it's cosine and not plain distance. Most embedding APIs hand back unit length vectors, so it's as cheap as a dot product. And it ignores magnitude and just compares direction.
So let me try to assemble the actual pipeline. Offline, ahead of time, I chop my documents into pieces, embed each piece into a vector, and dump them in a database. Then at query time, I embed the question and find the closest pieces.
You just described the entire architecture. And that split is exactly why it's fast. The slow offline pass. Chunk, embed, store. Costs hours, but you pay it once per document. The fast online pass. Embed the question. Retrieve the closest chunks. Paste them in. Call the model. Is just a lookup and a prompt. 50 to 200 milliseconds. Because the heavy embedding work is already done.
And the thing to really internalize, I think, is that the model never sees your documents. It only ever sees the handful of chunks retrieval hands it. So if retrieval grabs the wrong chunks, the model is answering blind.
That's the insight the whole field turns on. And it tees up the most important practical fact in this lesson. The single biggest source of bad RAG isn't the model, isn't the embeddings. It's chunking. How you slice the documents up.
Chunking, that sounds like the most boring step in the pipeline. Just cut the text into pieces. Why is that where everything dies?
Because the failure modes are brutal and they all trace back to it. Chunks too small and the answer gets fragmented across several pieces. No single chunk contains the whole thing. So retrieval can't hand the model a complete answer. Chunks too big and the embedding turns into a kind of soup. It's about so many things at once that it doesn't discriminate. One chunk seems to match every query. And the killer. Chunks split mid-sentence, and you retrieve a fragment that's just useless.
So is there a smarter way than just cutting every 500 tokens?
A few fixed size. 500 tokens with a 50 token overlap is simplest and works surprisingly well, but it breaks across meaning. Sentence-aware splits on real sentences. Structural is the big one. For markdown or code, chunk by headings or functions. Far better when documents have structure. And here's the experiment to run before tuning anything else. Take 10 real questions. Sweep your chunk size. 200, 500, 1,000. And measure whether the right chunk lands in your top 5. You'll usually see a 10 to 30% swing in recall just from that. Cheapest, biggest lever there is.
There was also a clever upgrade in here. Contextual retrieval, what does that fix?
The context loss problem. A naive chunk that says, their revenue grew 3% is meaningless alone. Whose revenue? Which quarter? So Anthropic's contextual retrieval prepends a short modal-generated summary before embedding. This is from Acme's queue to filing. Last quarter's revenue was 314 million. Then the original line. With hybrid retrieval and re-ranking, it cuts retrieval failures by up to 67%.
You said hybrid there. We've been talking entirely about embeddings and meaning. What does hybrid add?
It's a trap to rely on embeddings alone. They're brilliant at meaning, but bad at exact matches. Ask about Python the snake, and pure semantic search cheerfully drags in Python programming. So hybrid runs to searches, dense, the embedding similarity for meaning, and sparse. Classic keyword scoring, BM25, which nails exact tokens, acronyms, product names, error codes. You fuse both. Then a re-ranker, a cross-encoder, rescores the top 20 candidates against the query and reorders. Slow, since you can't pre-compute it, but very accurate, and one of the highest ROI additions you can make. Hybrid plus re-rank almost always beats embeddings alone.
And the final prompt? That's where you actually bound the model.
Right. Use only the context below. If the answer isn't there, say I don't know, and ask it to cite which chunk it used so you can catch hallucinations.
One thing I want to nail down, does more context always help? My instinct is to stuff in 50 chunks to be safe.
Resist that instinct hard. It backfires. Recent research shows accuracy drops off long before you hit the context window limit. 5 to 10 chunks is the sweet spot. 50 actively hurts. And the second thing, which is the real humbling caveat, RAG is grounding, not a guarantee. Only use the context reduces hallucination but doesn't kill it. A model can still misread or ignore what you gave it. And if your underlying documents are wrong, RAG just retrieves the wrong answer faster. And now it's cited as authoritative.
So garbage in, garbage out. Except doubled, because the bad text comes back wearing a citation, which means RAG isn't always even the right tool, I'd guess.
Exactly. Skip it when the data changes minute to minute, like stock prices. Just call the live system. Skip it when the whole corpus is small enough to drop into the prompt. 100 pages. Just include them. And skip it when the task is reasoning over everything. Like summarize the trend across these reports. Because that needs the model to read it all. Not a few chunks.
One sentence to take away.
Reg is chunk, embed, retrieve, ground. And the boring chunking step is where it lives or dies. So measure your retrieval recall before you touch anything else.
Fix the chunks, ground the model, and never trust bad data. That's the Datarekha audio guide. See you in the next one.